Greetings, Trig fans. All right, so today we're going to do is we're going to do some application problems, and these are basically bearing problems, and then we're going to apply law of sines and law of cosines to these bearing problems to figure out, basically to solve a triangle or to solve parts of the triangle that we need. All right, the key to all these problems is you got to draw a good picture. All right, so let's just get started with some of these problems here. The students mentioned in this video are from my 8th hour 408 class, year 2010-2011. All right. So let's get started here. Allie is at Conan and Naji is 20 miles due east. So the first thing you're going to do is due east. That's really key. Is you're going to draw an east-west line. Okay, very, very important. All right, and then this distance here is 20 kilometers. Allie walks to the bearing. So as soon as you see the word bearing, you draw your dotted line, and she walks to the bearing of 40 degrees. So this is 40 degrees. To Taco Bell. Sweet. She leaves Taco Bell with extra tacos for Naji. It's very nice with Allie. And walks at a bearing of 120 degrees. So here's another dotted line. Whenever you see, again, the word bearing, okay, you got to draw a dotted line. So this is what she's going. What's going on here is 120 degrees. All right, and that's all the information you're given. And then you're looking for this distance. You're trying to find the distance from Conant to Taco Bell. This is where Allie first started. Okay, a couple things we got to look at. First of all, you're always looking for supplementary angles. You're looking for complementary angles. You're looking for same side interior, alternate interior, corresponding. In this case here, if you notice, math fans, that 40-degree angle and this 40-degree, this is a 40-degree angle here, that red line. And the reason that is so is because their dotted lines are parallel, okay, and those are alternate interior. So this guy right here is 40 degrees. And then, of course, this angle right here is just 180 minus 120, which is 60 degrees. Okay, it's pretty easy. And what else can we do? Well, the nice thing about knowing, this is really key here. It's a kind of key word. It's due east of Allie. Okay, Naji is due east of Allie, which pretty much means this is a 90-degree angle right here. So if that's 40 degrees, that's 50 degrees. So what I'd like you guys to do is draw another triangle just to kind of help you see what's going on and put all your angles in here. Well, of course, 40 and 60, that's 100 degrees. Of course, this is not to scale, but that's okay. This is 50 degrees. So, of course, the triangle's got to be 180. So this is going to be 30 degrees. Okay, and we're looking, let's see, we also know bottom's 20, and we know x, and you guys are good. Once we have the triangle, it's really easy. I mean, you look at it and you go, okay, well, geez, this has got to be law of sines because we have a ratio. Okay, so we're going to say 20 over sine of 100 degrees is equal to x over sine of 30 degrees. And we cross multiply and solve for x. We get x comes out to be 10.15 kilometers. Okay, I'm going to round all my answers to 2 decimal places, to the nearest hundredth. Okay, pretty straightforward. Again, picture's huge. If you don't get the picture right, you can't get any of these problems right. Captain Kevin. Captain Kevin leaves port and travels north. So right away, I know it's a north-south line. Okay, so because he's down here and he's traveling north. He sees the yachts floating on a raft 30 miles away at a bearing of 20 degrees. Okay, well, that's pretty easy. That's 20 degrees. And here's the yachts, and this is 30 miles. After traveling north, he looks for the yachts again and notices that it is at a bearing of 130 degrees. So here's the deal. He's gone north, and now he's over here at this top point, and here's my bearing line. And this angle here is 130 degrees. It says, how far did Captain Kevin travel between the two observations of the floating yachts? All right, so there's your x. This is actually a really easy problem. The only thing I need to do here, math fans, is get this angle here, which of course is 180 minus 130, which is 50 degrees. So if that's 50, then of course this angle here is going to be 110 degrees because of, again, 110 degrees because of being 180 degrees in a triangle. All right, so real quickly, if I make my sketch, this is going to be x, this is going to be 50 degrees, this is going to be 20 degrees, this is going to be 110 degrees. and we just set up our law of sines. Of course, it's the same thing, right? We have a ratio, so we're going to say 30 over sine of 50 degrees is equal to x over sine of 110 degrees. Okay? And so we cross multiply and solve. We get x comes out to be 36.80 miles. Part of the deal too, math fans, is think about what makes sense. Okay, sometimes people just like put an answer down, they forget to do something, forget to take the square root, and it comes out to be some enormous number. I mean, think about it. If I'm traveling 30 miles and I notice, if I see the yacht is 30 miles away at a bearing of 20 degrees, if it's some really small distance, some really huge distance, probably not right. I mean, kind of think what makes sense in these problems. Okay. All right. So let's do number 3 here. Simeon, good old Simeon. Simeon leaves Conan and walks to Portillo's. Portillo's. He travels 13 miles at a bearing of south 60 degrees east. Okay, so it's just kind of, it's not a north-south line. It's just he's traveling, here's your dotted line, and south 60 degrees east. Of course, this is south at 60 degrees, and this is 13. It's close. It's kind of a bummer. So he walks to Jimmy John's. He has to walk 7 more miles at a bearing of north, so here's our new bearing line. And he's walking 7 more miles, and this is north 40 degrees east. Okay, and that's 7 miles. And it says after eating a huge sub, he has to walk back to Conan. How far is he from Conan? So this is the deal. We're looking for this value right here. We're looking for the red line. And please don't look at that red line and say, oh, gee, it's an east-west line, and come up with information. That's a really bad thing. The only time you can tell me it's an east-west line if I tell you somebody it's a due, they went due east or due west, or somebody's west of somebody or east of somebody, or it's an east-west line. It's the only time you can do that. All right. Otherwise, you can never assume anything. So the main thing here, math fans, is we have to determine, we have to look for alternate interior angles. In fact, if you see this 60-degree angle, and this is a 60-degree angle here too. You guys agree with that? Because it's alternate interior. Okay. And then this one's actually really, really easy, because isn't this whole angle then right here? Isn't it 60 plus 40? Wow, that was really easy. It's 100 degrees. So if I draw my new triangle, it's going to be 13, 100 degrees, 7, and x. Wow, that was actually pretty simple. Okay. Well, you can't use law of sines here because we don't have a ratio. Okay, we have an x and a 100, but we have no ratio. We need an actual ratio with 2 numbers. So of course, if you want to look at this, what's given here? It's side angle side. So it's law of cosines, which makes sense because we're finding that other side. Okay, so we're going to do x squared is equal to 13 squared plus 7 squared minus 2 times 13 times 7 cosine of 100 degrees. And guys, please use cosine. People like to use the law of cosines and they throw sine in there. That is like really bad. And don't forget this 2 also. Okay, it's a bad thing to miss. All right, so anyway, we get x squared equals 249.60. Take the square root of that, and we get x is equal to 15.80 miles. Okay? That's how far he's from Conan. Poor guy's got to walk all the way back. All right. Number 4, a mile is 25 miles due west of Kelsey. Okay, so here's a mile over here, and here's Kelsey. And it's due west. So we know it's an east-west line, and this is 25. All right. They want to eat lunch together at Sweet Tomato. Sweet Tomato. A mile travels at a bearing of 50 degrees. Okay, so draw your dotted line, and there's 50 degrees. And Kelsey, good old Kelsey, she travels at a bearing of 300 degrees. So here's 300 degrees, going all the way around, like that. Okay, how far did Amal have to travel to meet Kelsey? So, this is actually really not too bad. This is what you're looking for. You're looking for obviously that x there. And right, that since that's a 50-degree angle, we know that this is going to be 40 degrees. That's pretty easy. And the deal is we need to figure out this angle right here. Well, remember, I know we've covered this in class. You could always say, yeah, it's 360 divide or minus 300, but that gives you this top angle here. And I don't really want to know this top angle here. I want to know that bottom angle. So if I just subtract 270 from that, I get 30 degrees. That's just a heck of a lot easier. So that means this is 30 degrees. And then, of course, this one is going to be 180 minus 70 or 110 degrees. Okay, you have to pardon my voice. I have a cold, and I'm trying to do this video. Okay. Okay, so we pretty much have everything. Let's draw the triangle. And this is 25, this is 40 degrees, this is 110 degrees, and this is 30 degrees. And of course, what are we going to use? Well, we got a ratio, don't we? Oh, we're looking for x. So we're going to use law of sines. Pretty straightforward. So 25 over sine of 110 is equal to x over sine of 30. Cross multiply and divide, we get x equals 13.30 miles. Okay? Pretty easy, pretty easy. All right, number 5, Sammy. Good old Sammy. Sammy leaves Conant and travels at a bearing of 25 degrees for 40 kilometers, or as we like to say, kerfometers. She then changes direction. Okay, so let's start here. She leaves Conant and travels at a bearing of 25 degrees. Okay, and this is 40 kilometers. Then she then changes direction and travels at a bearing of 35. So right here, let's extend this a little bit more. She changes direction and she's going to go 35 degrees. Now, it's definitely not to scale, but I got to show it a little bit so you see it's a change in direction there. And she goes for 70 kilometers here. And then it says how far is Sammy from Conant? So this is what we're looking for. It's a really bad triangle. Okay, kind of like that. It definitely is a triangle. We need to get some information here. So the first thing we're going to do is, again, notice guys, we've been seeing this a lot now. This is also 25 degrees. All right, and I know doing this problem that I probably have to get this angle right here. Do you guys agree with that? Because look what I have. I've got the 40 and I've got the 70. It's on either side. So you need to probably at the angle in between there. Well, I've got 25 degrees, and don't you guys agree? If this bearing is 35 degrees right here, the rest of this guy right here, isn't that just 180 minus 35 degrees, which is 145 degrees? Okay, that means the whole line, this whole line right here, is going to be these two values added together. So that's going to be 170 degrees. So your new triangle, I'll kind of roughly sketch it, is going to be 170 degrees. And this is going to be 40. And this is going to be 70. And then you're looking for that red value x. Okay? Well, again, what are you going to use? Don't have a ratio, so we're going to use law of cosines. So we're just going to do x squared equals 40 squared plus 70 squared minus 2 times 40 times 70 cosine of 170. Okay, so x squared comes out to be 12014.92. Take the square root. X is 109.61 kilometers. Okay? Wow, Sammy's far from Conant. Poor kid. Okay, some familiar faces here. This is very exciting. The ox and the soy are 50 miles apart on an east-west line. Oh, I like that. I like east-west lines. So we're going to draw an east-west line. And this is the ox over here and the soy over here. Very scary. And it's 50 kilometers apart. The ox walks at a bearing of 100 degrees. So here's 100 degrees. It's going down, isn't it? Then 100 degrees right there. Okay, because 50 would be on the east-west line, but it's 100. to get the hot dog stand. From the hot dog stand, he walks at a bearing of 35 degrees to meet up with the soy. So here's the hot dog stand, and here is an angle of 35 degrees. Okay, and that's it. And it says how far was the Yox's original position from the hot dog stand. So we're looking for this value right there. Okay, so obviously having an east-west line is really nice because this value right here is just 100 minus 90, which is 10 degrees. All right, and you know, there are a couple other things we can get here too. If that's 10 degrees, don't you guys agree that this is a right angle here for both of these? Right? It's a right angle. So if that's a 90-degree angle and that's 10 degrees, don't you guys agree that this angle right here is going to be 80 degrees? Because it's 90 degrees here, so the other two angles have to be 90 also. And if that's 10, that's got to be 80 degrees. Okay, there are other ways to figure that out too. I could just to show you, right? If that's 100 degrees, don't you guys agree that this is 80 degrees? And aren't these alternate interior angles also? So you can see there are a lot of ways to get to different angles here. All right, and okay, so and then I have, of course, this other angle then. Okay, you can do that as 90 minus 35, or however you want to figure that out. A lot of different ways, but it turned out to be 55 degrees for that one too. Okay, because 55 35 is 90, plus 90 is 180, so that little triangle is also 180, right? Okay, so let's draw a nice bigger version of that triangle. This one is 115 degrees because now I'm adding 80 and 35, so 115 degrees. And of course this is 10 degrees, and we said this was 55 degrees. And this is 50 over here. And we're looking for x. Well, of course we have a ratio, and so we're going to do 50 over sine of 115 degrees is equal to x over sine of 55 degrees. And you're like, wait a second, Mr. Curvis, you can't take the sine of the biggest angle. You told us you can't do that. And then you're thinking, oh, wait a second, you can take the sine of the biggest angle. You just can't find the biggest angle. Ah, very interesting. Okay. So anyway, cross multiply and divide, we get x equals 45.19 kilometers. Okay? Pretty easy. All right. So next one. R. Pete. Okay, good old R. Pete. He leaves Big Bowl. I guess they have big bowls there. And travels on a bearing of 120 degrees for 50 kilometers. All right, this is actually a really, really good problem. It's a little challenging just because of the drawing here. But he travels on a bearing of 120 degrees. So let's do that. And here's 120 degrees for 50 kilometers. He changes course. So I'm going to draw another bearing line because he's got a new bearing. And he travels at a bearing of 280 degrees. Well, don't you guys agree this is like that way? Because it's going all the way around. It's a little bit more than 270. And he does that for 20 kilometers. And this is 280 degrees. He is tired and cold, poor kid, and wants to go back to Big Bowl on a straight path. So it says, how far is he from Big Bowl? So you want to know this distance right here. All right. It's not necessarily the easiest problem just because you're looking at it. You guys should realize I've got a side here and I've got a side here. What am I looking for? I'm probably looking for this right here. Okay, probably looking for that angle. So I've got enough information. Let's pull a couple things together here. First of all, look for alternate interior angles. It seems to be the theme here. And do you guys agree if this is 120 degrees and there's my transversal, isn't this also 120 degrees? Oops, I should have extended it a little bit more. Sorry. That line. There we go. Don't you guys agree that's 120 degrees? And now, the way you actually go about doing this is you know you got to do some sort of subtraction from it. But if I add this line, don't you guys agree that this is 180 degrees? So isn't the whole line 180 plus 120, which is 300 degrees? That's that whole red line. And the black line that you see, it's 280. So if I subtract the red line from the black line, minus 280, I get 20 degrees. There you go, man. That's it. This little angle right here is 20 degrees. Okay, so now you're all set. That's 20 degrees. This is 20 kilometers, and this is 50 kilometers. Okay, not too bad. And of course, what are we going to use here? We're looking for that red line here, so x. Of course, we don't have a ratio. We're using log cosines. So it's going to be x squared equals 50 squared plus 20 squared minus 2 times 50 times 20 cosine of 20 degrees. So we had x squared is equal to 1367.91. So x comes out to be 31.95 kilometers. Okay? All right, so that's not too bad. Just a little careful, got to be a little careful, but you notice our theme here, math fans, alternate interior angles and angles that are supplementary. Okay? All right, let's do our last one here. Good old Rita and Ryan, my niece and nephew. All right, Rita is at Target. She likes Target. And Ryan is at Best Buy. He likes Best Buy. Target is west of Best Buy. So let's draw this. As soon as you see that word west, man, you know it's an east-west line. And Rita leaves Target and walks for 8 miles at a bearing of 140 degrees. All right, so that's pretty easy. And that's 140 degrees is here. Ryan leaves Best Buy. Can't imagine them leaving. And walks at a bearing of 210 degrees. So it's going all the way around, and this is about 210 degrees. So here. A little messy there. Okay, and this is 210 degrees. And she walked for 8 miles. So there's an 8 here. We don't know how far Ryan went. They're meeting for lunch. This is lunch, L-U-N-C-H. It's one of my 3 favorite meals of the day. How far are Target and Best Buy from each other? So you're looking for this. Okay. Well, again, this is pretty easy. It's an east-west line, math fans, and that actually makes it really, really easy. I'm going to figure out this angle right here. Right? That's easy. It's just saying 140 minus 90, which is 50 degrees. That is like super easy. And then I need to figure out this angle here. Well, isn't that whole thing 270 all the way around? So isn't it 270 minus 210, which is 60 degrees? Okay. And that's it. So let's draw our triangle here. This is 8. This is 60 degrees here. This is 50 degrees. And then, of course, that's 110 degrees, and we got 70 left over. So that's here. And we're looking for the distance between Target and Best Buy. All right, so let's just set up our nice little, obviously we know it's a law of sines because we have a ratio. So it's going to be 8 over sine of 60 equals x over sine of 70. And we cross multiply and solve. X comes out to be 8.68 miles. Okay? So that's it, math fans. That's all the different application problems. It's very similar to your homework. You should have this sheet in front of you when you are doing your homework to help you with all the different problems. But that's what your quiz is going to be on, or your test or review sheet. But you got to know how to do bearing problems. All right, that's it, math fans. You have a great day. Adios. Goodbye.